So today we're going to find the domains of all the combined and composite functions that we were doing last time. So here are the domain restrictions that you have to look out for. You cannot have a zero denominator, is the first one. And those are the ones I call the troublemakers. Like you have to kick them out. So you're not allowed to divide by zero. So let's just make up a quick example. Give me some numbers. Good. 2 over x minus 3. So if that's your function, what's the restriction? Like who's getting kicked out? 3. 3 minus 3 would be 0. You're not allowed to divide by 0. So your domain would be everything except 3. You want everything to the left of 3, everything to the right of 3, but not 3. So that's your first restriction. You can't divide by 0. That's the rule. Okay. The other restriction we're going to look at is you can have no negatives under an even root. And mostly we look at square roots, but you guys understand there are cube roots and fourth roots and fifth roots. Like, do you remember anyway, the even ones are the ones that are a problem. So a square root, a fourth root, a sixth root, an eighth root, any of the ones that are even, you can't have a negative number underneath of those. So let me make up an example for that as well. Give me a number. 5. Say you have square root x minus 5. Let's think of that from a graphing perspective. This is back to unit 1. Remember we did all the transformations? Did that graph move left or right? Be careful. Moved right. So, and you don't have to draw a graph for all of these. I'm just showing you visually what this would look like. It went right 5 and looks something like that. I know I got really close to the end of the paper, but it's that like half parabola turned on its side. So what would that domain be? If you sweep left to right, what would your domain be? Yeah, 5 comma infinity. And we would put what with the 5? Bracket or parenthesis? Bracket, good, because that point is actually there. So it would be 5 to infinity. If the graph moved to the left 5, like if it was over here, it would be negative 5 to infinity. Do you see what I'm saying? Okay. So I usually just think of it from like a graphing standpoint. So those are 2 rules that you have to follow. You can't have a 0 denominator and you can't have a negative under an even root. This is going to have to stay positive, but I usually just think about like what the graph would look like. So for combined functions, and we're really just going to look at f plus g, we're not going to look at the like divided and multiplied ones. You're just going to combine the 2 domains. So you find the domain of each of them and then just combine them. That's kind of it. So we're going to write the domains for each of these, and then we'll write the domain for the f plus g of x. So let's look at the first one. What would this graph look like? Because it has a squared, what would the graph shape be? Good, quadratic, parabola. It would look like this. What's the domain of every parabola? All reals, everything. That domain does not have a restriction. Quadratics don't have a restriction. Absolute value doesn't have a restriction. You know what I mean? Like a V shape. A linear doesn't have a restriction. There's a lot of them that are just like all numbers. Oh, this is the one that you guys happened to make up when I said shout out a number for me. This domain, the graph moved to the right 5. So it would be 5 to infinity. So when you go to do the domain of f plus g, like adding them both together, this one you don't have to worry about. Like it just doesn't matter because there's no problem. Do you get what I'm saying? It's like that function's like, I'm good. It can be everything. This is the one that has a problem. And so that's going to be your domain. This one you don't have to worry about because it's everything. So the domain would just be what the other rule is. If one of them's all reals, you just don't have to worry about it. Does that make sense? Like it's everything. So just forget it. So for this one, who's your troublemaker that you're going to have to kick out? 9. Get rid of 9. 9 is causing problems. It's making a 0 denominator. So you have to get rid of 9. And then what would this graph look like? If you were to graph that, what kind of like a shape would you get? A line, right? A line with a slope of 7. Remember y equals mx plus b, up 7 over 1. Anyway, what's the domain of a line? Yeah, all reals, everything. Lines are cool. They're like, we're good. So if you combine the two together, you don't have to worry about this one because it's everything. So your domain would just be leaving out 9. So again, if one of them's all reals, like you're really kind of good to go. It's just going to be whatever the one that has a problem is. Now these ones, they're both going to have restrictions. So we're going to have to combine them together. Who's your troublemaker for this one? Like who's getting kicked out? -2. Get rid of -2. And then this one, what direction did it move? It went left 5. So it is going to be bracket -5 to infinity. It went to the left 5. So now we have to combine both of those together. Think about your number line. Which is the smaller number, -5 or -2? -5 is like more negative, right? So you want -5 onwards, but you also need to leave out -2. So it's going to look like this: -5 with a bracket to -2, and then -2 to infinity. You're combining the two together. Did that sit well? Is there a question about that, or you're just combining the two together? So let's try that again. For number 4, what number do you have to leave out for this one? 6. Get rid of 6. Causing problems. 6, get out. And then how about this one? Yep, -1 with a bracket to infinity. It moved left 1. So if you combine the two together, you want to go from -1 onwards, but you have to leave out 6. So how's that going to get written? -1 with a bracket, good, until 6, union. You guys got it. I didn't put any more examples of this because I felt like that would be good. Have we got it? Like we're okay there? I'm not trying to torture you. These are the ones I want to spend more time on because these are the ones that tend to be kind of tough. So those are our combined ones. You're just adding them together. You just combine the two domains. When you put one function inside of another function, it gets a little bit more complicated. So I'm going to draw us a picture for this. Here is where all of the x's live. Those are all of your inputs. Bless you. And so if you put them into function g, what you get back is g of x. Did your Algebra 1 teacher ever teach you functions as like a function machine, like an input and an output? Sometimes teachers will show it like that. Like, I don't know if they actually draw a little machine, but it's like you input x's and you get back g of x, or yeah, f of x, or whatever you call it. So all of this would be the domain of g, and then this would be the range of g. So domain is everything that gets inputted, range is everything that you get back out. It's like a little function machine. But remember, it's like the telephone game. You take that new output and put it into another function. So we're going to put that into function f, and what you get out is f of g of x. So it gets passed along. And so this would be the domain of f, and this would be the range of f. So here's where it gets a little complicated, and that's why we're going to do a lot of practice with this. Your function g, or the inside one, don't get hung up on f and g because you can reverse them, but the inside one has to comply with whatever the domain of the outside one is. Like these have to follow the rule. Do you understand what I'm saying? Like these have to match up, or you can't pass it along to the next function. Like if there's a rule there. Do you guys get what I'm saying? Everyone's just kind of staring at me. I know it's Wednesday and we're tired. All right, so to find the domain of f of g, there's two things. Number one, if g of x, which I'm calling it g here, but it's actually, let me call it the inside function, because you can reverse them and then it wouldn't be g anymore. If the inside function has a restriction. And what I mean by that is it's not all reals. Like there's some kind of problem, like you have a troublemaker or something else going on. If the inside function has a restriction, keep it. So if the inside function has some kind of rule, you're stuck with that. Period. End of story. Like you are going to be stuck with that. The inside function has some sort of rule, keep it. And secondly, the inside function must comply, which, do you guys know what the word comply means? Like you all have to comply with the code of conduct here at Mechanicsville High School. What does comply mean? Like follow the rules, okay? So the inside function must comply with the domain of the outside function. And sometimes it does anyway, and there's not a problem, okay? It's like already following the rule. That's like when your mom comes in your room and she's like, do your homework, and you're like, geez, I already did. It's like you're already following the rules. So sometimes it's fine, but sometimes you have like a secondary restriction that's gonna happen there, okay? We're gonna practice a bunch of these because it's gonna take a little bit, all right? Now, these kind of like, I left you spaces for all of these, but my suggestion is separate problem 5 from problem 6. Like just draw a line across the paper so they don't bleed into each other. And here's the other pep talk I'm gonna give for this. If you struggle with the domains of the composite functions, I get it. It's hard. This is not going to be an easy topic, but notice how many blanks there are in here. If you can get the domains of each of these, which I think you'll be fine on, and if you can find the composites, that's what we did last class, which I think you'll be fine on. Those answers are actually only one small part of this, so you can still actually get most of the points, even if you struggle with this. Does this make sense? Like, you can still get most of the points even without understanding it, is what I'm saying. So try, but don't stress. No stressing, right? So let's look at this first one. What is the domain for this? It's going to be a quadratic, so all reals. And I make it a point for everything that you do, so like you'll get that. Okay. And then how about this one? Yeah, why is that all reals? What would this look like? It's a line. All right, so let's find f of g. Which function gets plugged into which? Good, g gets plugged into f. Draw the little arrow if it helps you. So that means this x minus 5 gets plugged in over here. So it's going to be 3 and then x minus 5 squared, which means that I'm just going to go ahead and write it twice. Squared means you're going to have to write it twice. You're going to multiply that out. And then plus 4. So we'll have 3 and then what? If we multiply these together, what are we going to get? Good. X squared. Perfect. Nice job, guys. And then I'm going to go ahead and write the answer on the line. We're going to distribute the 3. It'll be 3x squared minus 30x plus 3 times 25 would be 75 plus 4. Good. Perfect. 79. And again, I think you'd be fine with that. That's what we did last time. Just multiplying stuff together. All right, now let's do g of f. This time f gets plugged into g. So that means this entire function just gets plugged in over here. So you would have that whole function minus 5. And so that would be 3x squared minus 1. I basically threw those on here just to review what we did 2 days ago, because when you go to do the domains of the composite functions, this is for the domain of f of g, this is for the domain of g of f. Did either of these have a problem? Then are either of these going to have a problem? No, so they're just both going to be all reals. If there weren't any restrictions to begin with, then there aren't going to be any restrictions in the answers. Like, there's not going to be a problem. Everybody was just groovy and cool. Nobody had any issues. We'll do number 6 and then we'll do our break. Then we'll be halfway through. All right, what is your domain for x squared? All reals? And then how about this guy? Bracket and then what? Good. Bracket -4 to infinity. All right, so for f of g, g gets plugged into f. That means this square root of x plus 4 is getting plugged in over here. So what's going to happen there? If they cancel, good, you just get x plus 4. And then for this one, f gets plugged into g, so that means this x squared gets plugged in over here. You'll have square root x squared plus 4. You cannot simplify that. I know it's like really tempting because 4 is also a perfect square, but they're not separate things. It's an x squared plus 4. Put a hug around it if you think you're going to forget. Okay, now we did have a restriction in one of these. Just listen. You start with the inside. For this one, which one was the inside function? G. Does G have a restriction? You are stuck with it, period. If that inside function has a rule, you keep it. Then look at the outside. Does F have a restriction? No, we're good. So this is just our answer. You just keep the one from the inside. So like if you're looking at the 2 rules I gave you, if the inside function has a restriction, keep it, we did. Inside function has to comply with the domain of the outside function, but the outside function didn't have a rule, so we didn't have to worry about it. All right, now let's look at this one. Which one's the inside? F of x. Does F have a restriction? Cool. All right, now look at the outside. Does G have a restriction? Yes. Hey, F of x, you better stay bigger than -4 or no dessert. Do you get what I'm saying? Like it has to follow that rule. So f of x, which is this x squared, that's this function, has to stay bigger than -4. That's the rule. So you set up a problem and then you kind of work it out. And it's either true all the time or you get another restriction. Hey, f of x, better stay bigger than -4. What do you think about this? X squared bigger than -4. If you square something, it's what all the time? It's positive all the time. So wouldn't this be true like always? Yeah, this is always true. Again, it's like your mom comes in your room and is like, finish your homework. And you're like, I already did. Geez, I did it already. It's like you're already following the rules. So it's going to be all reals. Thank you for letting me finish that thought. Go ahead. Okay. All right, so we're going to go through and just put the domains and then the f of g and the g of f. So what did you guys think for the domain for this first one? Oh, bracket. Oh, you're even telling me bracket? 9 to infinity. Perfect. And then how about just regular old x squared? All reals. Awesome. All right, for here, g gets plugged into f. So that means this x squared gets plugged in right here. It will be square root x squared minus 9, and you cannot do anything to that, so just do nothing. We love nowhere. You do not have to put the parentheses. I just put it there as a reminder. All right, plugging f into g, this is going to get plugged in over here, so you're going to have square root x minus 9 squared. Now in that case, the square root and the squared are going to cancel, and so you'll just have x minus 9. So see, out of 6 blanks, you can really answer 4 out of the 6, like even if you struggle with those. All right, for this one, we're going to leave out who? Who's the troublemaker? 0. Leave out 0. And then this is a line, so all reals. All right, if you plug G into F, what are you going to get? This is getting plugged in over here, so what will that give us? Good. 1 over x plus 3. When you plug f into g, it's going to be 1 over x and then plus 3. They are subtly different. All right, and then how about this one? 1 to infinity. Good, it moved to the right one. And then this is a parabola, all reals. Plugging g into f, this 1/4 x squared gets plugged in over here. There will not be anything that you can do to that, so just leave it alone. and then plugging f into g. This gets plugged in over here. And in that case, you can cancel out the squared and the square root because you're squaring the whole thing. And that'll just leave you with x minus 1 there, and then you'll distribute the 1/4. So it'll be 1/4 x minus 1/4. Again, I had us do that just to calm you down because people panic about the domains of the composite functions because it's tough. And I'm just trying to, again, illustrate for you. Look, you can answer the majority of it without that. Okay, so now let's go back and do this part. Start with the inside. Which one's the inside function here? G, good. Does G have a restriction? Fantastic, G is good to go, right? Does F have a restriction? Yeah, hey, G of X, you better stay bigger than 9 or else no dessert, all right? So you're gonna take G of X, x squared right here, and you're gonna say, hey, you have to stay bigger than or equal to 9. Hey, G of X, you better stay bigger than 9. You have to comply with this rule. Now that's not true all the time, all right? You would need to square root. I made it a perfect square on purpose. What's your square root of 9? And -3, okay? When you do the negative, what do you have to do to your symbol? Flip it. So you're gonna get x is bigger than or equal to 3, x is less than or equal to -3. So if you think about your number line, you want everything bigger than 3, smaller than -3. So it's going to look like this. You want -infinity to -3 bracket, and then union 3 to infinity. If you were to graph this, here's what it would look like. And I absolutely love these, which is why I put this on here. You'd have a point at 3 and a point at -3, and it goes like this. It looks like little alien antenna or something. Like that's what the graph looks like. That's so cute. I love those. So it was, hey, G of X, you better stay bigger than 9. And then we worked that out. And if you graph it, this is what it would look like. And I just, all right, for this one, F is the inside function. Does F have a restriction? Keep it, put the phone away. You're stuck with that. Does G have a restriction? No, so there's no problem to set up. This is just your answer. It's when the outside function has a restriction that you end up having a problem to set up. If the inside function has a restriction, you just keep it and that's it. All right, so let's try this one. Does G have a restriction? No, it's all reals, good to go. Does F have a restriction? Can't be 0. Hey, G of X, you better not equal 0 or else, all right? So we're gonna take G of X and say, all right, you're not allowed to be 0. 0 is a troublemaker. It's like, hey, you can't hang out with him. He's a problem, all right? And then you would solve that. Subtract over the 3, X is not allowed to be -3. And so you would want everything except -3. Now, if you want to skip that work and just write the answer, I'm okay with that. How could you tell it was -3 without doing any of this work? Like, that's what would make this, are you guys following me? That's what would make this 0. If you want to just write that answer and skip that work, I'm totally cool with that, okay? All right, does F of X have a restriction? F is the inside one. Does F have a restriction? You are stuck with it, just keep it. Does G have a restriction? No, so there's no problem to set up. You just keep this answer. Again, when the inside function has the problem, that's fine, just keep it. It's when the outside function has a problem that you have to like do some work. All right, does G have a restriction? Again, start with the inside. No, G is fine. Does F have a restriction? Yes, so this is where you have a problem. Hey, G, you better stay bigger than 1. G, you better stay bigger than 1 or else, okay? So you're going to take this G of X and set it bigger than 1 and then work that out. What would you do to both sides to solve that? Yeah. Multiply by 4. and then square root. I made it a perfect square on purpose. You'll get x is bigger than 2, and then x is less than or equal to -2. It would look like this. It's like little alien antenna. So how would you write the answer? Yep. To -2, good, bracket, union, 2 to infinity. Perfect. And it would look just like this one, except the points would be at 2 and -2. All right, does F have a restriction? Yes, keep it. Does G have a restriction? No, fantastic. So what's our answer for this? Yep, bracket 1 to infinity, you just keep it. We're gonna do the same thing on this side. I want you to go through and do just the domains of the functions and the f of g. Okay, and also for number 12, we're not gonna do this one. It gets insanely ridiculous, bless you. So we're gonna skip that one. Okay, but just again, I'm gonna shut my mouth. I want you to talk to each other. You did a great job on the other page, just do that again. Okay, we're just gonna practice 3 more. Just do the domains and the f of g. We'll do this part together. All right, so who is the troublemaker number for this one? -3. Leave out -3. He's causing problems. All right, if you were to graph this, what shape is an absolute value? It's a V. Goes left and right forever, so that domain is all real. That's going to be everything. And then walking around just checking on you guys, this went well. You can't combine these together. When you plug G into F, you're going to get 1 over absolute value x plus 2 and then plus 3. You cannot combine them together. So just do nothing. Just leave it alone. And then same thing over here, plugging F into G, you're going to get a great big absolute value, 1 over x plus 3 plus 2. Do nothing. We love no work. Just leave it alone. Okay, we'll do these together. For number 11, who are you kicking out from this one? 7. Get rid of 7. And then this one, everything. Everybody's invited to the party. All right, plugging G into F, same thing. It's going to be 1 over absolute value x plus 4 minus 7. Leave it alone. Plugging F into G, you're going to get a great big absolute value, 1 over x minus 7 plus 4. Do nothing to those. Basically, if there's an absolute value, do nothing. Just go with that. All right, and then for number 12, how about this domain? It would be bracket and then what? Perfect. We've left 2, and then this one, we're kicking out 6. All right, plugging G into F. This is getting plugged in over here. So it'll be square root all of that, 1 over x minus 6 plus 2. Again, there's nothing to be done there. You get like a great big mess. And this domain is an awful mess too, so I just had to skip that one. Like it gets ridiculous, so I was just. All right, and then plugging F into G, you're plugging this square root in over here. So it'll be 1 over square root x plus 2 minus 6. Leave it alone. Did that go okay? Like walking around, it seemed like you guys have got this, so it's awesome. All right, so let's go back and do the domains of the composite functions. Start with the inside. Does G have a restriction? No, cool. Does F have a restriction? Yes, all right, this is where you have to set up a problem. Hey, G, you better not equal -3. G, you better not hang out with -3. He's a troublemaker, all right? So you're gonna take G of x, this absolute value of x plus 2, you're gonna say, hey, you can't equal -3. That's the rule. You have to comply with that rule. You cannot equal -3. And we were kind of having this conversation over here, but it was a good one, so I'm gonna say it for everybody. Remember the 2 rules. You're either leaving somebody out, it's either a not equal to, or you have to stay bigger than a certain number. It would be a greater than or equal to. Those are the 2 rules. It would either be you're not equal to something, or you're greater than or equal to something. Okay. Now let's think about this. If you absolute value something, it would always be what? Positive. So that's always positive. Can it ever equal -3? No, so this is always true. So it's going to be all reals. Again, it's like when your parents come in and yell at you like, hey, I told you to clean up your room. And you're like, geez, I already did. Like you're already in compliance. So, so there's no restriction. All right, and then for this one, does F have a restriction? Yeah, you are going to do what with it? Keep it. You have to keep it. If the inside function has a restriction, keep it. Does G have a restriction? Great. And the outside function is good to go. You don't have to set up a problem. You're just going to keep this answer. So again, if the inside one has the problem, you just keep it. Right, number 11, does G have a problem or a restriction? No, fine. Does F have a restriction? Hey, G, you better not do what? You better not equal 7. 7's a problem. I don't want you hanging out with him, all right? G, you better not equal 7 or else. Now, when we did this one up here, it was a negative number, so it's just always true. This one, we're going to actually be able to work out. And I'll see if you remember this from last year in Algebra 2. I know it was like a year ago. You're going to have x plus 4 can't be 7. And you're going to have x plus 4 can't be -7. Do you remember the definition of an absolute value? It's a distance from 0. Whenever I used to teach Algebra 2 like a million years ago, it feels like. I would stand up here, I'd be like, hey guys, I'm on 0. I want to be 7 units away from 0. How can I do that? Well, I can go to 7 or I can go to -7. So that's why you get both answers, okay? And then we're going to work these out. You would subtract 4, so x can't be what? 3, x cannot be 3, and x cannot be -11. So we want to leave out 3 and -11. So you have 2 troublemakers that you're leaving out here. Why am I leaving out the -11 first? It's smaller. You got to go smallest to biggest. It's a number line. All right, start with the inside function. Does F have a restriction? Yes, what are you going to do with it? Keep it. Does G have a restriction? No, so your answer is just leaving out 7. That's the best way that it turns out, is when the inside one has the problem, you just copy it over. Now this one, they both have restrictions. Ooh, okay. This one we're not doing, that turned out real crazy. Does F have a restriction? Yes. You are stuck with it, -2 to infinity. Does G have a restriction? Yes. Hey, f of x, you better not do what? You better not equal 6 f of x or else. So you're going to take this f of x and you're going to say, hey, you better not equal 6. 6 is the troublemaker over here. And then you would work that out. How do you get rid of a square root? Square it. Good. 6 squared, 36. And then subtract the 2. X is not allowed to be 34. Don't write this because this is wrong. I'm going to show you the common mistake is people get that and they'll do this. I get why that happens and it's almost right. It's like so close. But if you do that, you forgot about the original restriction. Again, this one, they both had one. So you have to include this -2 to infinity. So just instead of starting with -infinity, you have to start with -2. Do you see what I'm saying? Like you have to include that too, because they both had a restriction. So you want -2 to infinity. It's just we had to leave out 34. Let me show you why. Like humor me for a second. If you try to plug in 34, watch what happens. 34 plus 2. 36, square root of 36, 6, and 6 minus 6, 0. And you can't divide by 0. Do you see what I'm saying? Like, that's why that gets left. Anyway. Oh, so if you are just leaving something out, it's a not equal to. And if you have a square root, or I write any even root, I'm only going to give you square roots, but it's true for any even root, then it would be a greater than or equal to. So it depends on which rule you're breaking.